what's actually in the vaccines. Dr. Ryan Cole was able to secure Johnson & Johnson, Pfizer, and Moderna vaccines so that we could take a look at them. Let's take a look at what we found.
We're going to go to the microbiology lab, and we have a clean HEPA-filtered hood in there that's sterile, and we'll pop the vaccine vials under that hood, go ahead and put some of the contents on the slides, cover slip them, and then you and I can look at them under the microscope. All right, so we're going to set these aside and let them thaw, and we will go grab the J&J. I have those in my office. Good. Those are kept at room temp.
Great. So this is Johnson & Johnson.
Yep. Right now we're on about 2000x magnification. See, there's our little wigglers. Yeah. So, I mean, that's just typical. That's just fluid flowing. There's an electrostatic charge when you get down to particles that small.
What about this hairy looking thing there?
That's a really good question. When you ramp something up this fast, you know, how much debris do you get in the manufacturing process? And that's a good question. Is it, you know, gasket debris? See, that looks like a glass shard to me. Yeah.
So, like, I get we're looking at, like, at a microscopic level, but I don't want shards of glass moving through my bloodstream and my heart and everything else.
How pure are these? There's no guarantee. And I know from, you know, Japan rejecting millions of Moderna vials, impure. These are ramped up at warp speed. We know it usually takes many years to get a drug product safely to market with pure manufacturing. We look earlier last year in 21, the European Medicines Agency, you know, they were getting vials that were only 55% pure. So you're getting fragmented RNA instead of the full sequence, you know, to make whatever it's supposed to be making. Do you want a pure product in your body or not? So you saw we did that under a laminar flow hood, HEPA filtered, so very clean environment. But even by the time that I brought those slides to here, you saw there was some dust particles on the cover slip. Yeah. So when one's doing microscopy of certain types, that's why you have to be very careful and then know what you're looking at without jumping, you know, to conclusions that may be, you know, off the beaten track. And that
is that like one of the, you know, adenovirus
that
vectors?
Probably contains thousands of particles of adenovirus just in that one little, well, maybe hundreds. Just in that one little floating particle going by. You know, that's the carrier. Per J&J's application to the FDA, there's trace human protein, trace human DNA.
And now those proteins, that would be aborted
fetal cell fragments, yeah. And if I put my protein in you, you're going to have an immunologic reaction to that because proteins from different people are immunogenic in other people. And that's why when you go to the blood bank, they're trying to match as perfectly as possible your blood to someone else's blood because blood cells even have tons of different proteins on their surface, red blood cells. So you have to match protein group to protein. There's knowingly traced proteins that can be immunogenic, causing an immunologic reaction. Let's take a peek at Moderna here. Interesting, some of those particles are a little more elongated. Those should be the lipids containing, you know, thousands upon thousands of particles of mRNA sequence. But I don't know what those rod forms are. Again, that looks more like a debris-like particle to me. And again, it's not mineral. But yeah, they're clumping around a piece that's on there. And again, if I go up and down, it looks like we may be looking at it on edge, like it's more of a sheet instead of a rod. And again, so that goes to the question of what other carrier agents are in here besides lipid. We sent some of these off for analysis, and it'll be interesting to see. So here we have Pfizer. We did 2 vials. This is the first lot. It's interesting, these look even a little tinier than Moderna did by a little bit. Now this is interesting right here. Okay, just like we saw with the other. Some of them are more elongated, a bunch of particles sticking to another particle in there.
Yep.
Not quite as rod-like as the other that we were saying. Oh, there's one. Oops, there's one past there. Yeah, that one, yeah. And again, there's another one floating by up there, kind of in a sheet.
We saw it in Moderna. We're seeing it now in the Pfizer, these sort of rods or sheaths.
You know, is it a chemical of some sort bonding together?